Awesome. Yeah, so I'm Rich.
I'm Imo.
If you've been paying attention to .NET for a long time, you probably have seen us before. So today, we're going to talk about the platform layer and what's new and exciting in .NET 9. So let's, hopefully this slide deck appears. There we go. Yeah, so this is basically just broken up into three areas. I'm going to talk about the first one and the last one, and Emo's going to talk about the middle one. So it's a Rich and Emo sandwich, which is clearly what everybody wants. Okay, let's talk about. And so we're just showing a small subset of what we've built over the last release. There's actually just a ton more than is here, and please do look at our release notes. The what's new docs for runtime libraries and SDK are just full of stuff, and we put a lot of effort into documenting those. Okay, so we're going to talk about the runtime first and start with the garbage collector. We made major changes in the server GC this time around. So in this release, we focused on memory reduction. In most prior releases with server GC, we focused on throughput and improving that. So the basic, a couple more things. With the .NET 9 implementation, the server GC primarily grows and reduces memory based on what the application actually needs, and also on the allocation rate. So for example, if the application is getting a ton of traffic, then the GC might choose to let memory grow. And also, if things start to go in reverse, then it might reduce memory over time, which is excellent. With .NET 8, the GC took the amount of resources that were available on the machine, memories and CPU cores, as kind of like a primary input, and then would start with a lot more memory and would typically not let it go. And so you basically, in practical terms, .NET 8 starts big, .NET 9 starts small, and has a bias to staying small. You're probably familiar with these tech and power charts that we like to show. So the big thing is the part on the right. So we've been able to reduce memory for this tech and power benchmark by just an absolute dramatic amount. And you can see that, you can easily guess that the memory usage for .NET 9 probably started small, and it was able to maintain, I almost said 1,700. It's actually 1.7 million requests per second at this much lower memory rate. So that's super impressive. And the throughput, as you can see, is even more than before. Okay, so just a couple more points on this is in order to deliver this memory reduction, the GC actually does have to do a bit more bookkeeping than it did before, so it's a bit more computationally intensive, so it does trade a bit of throughput for the lower memory. Depending on the application, this might not even show up. So with the chart that we just looked at, you can see that whatever the other performance improvements were in .NET 9, they overshadowed whatever this cost was. So for that application, it's clearly a win. Server GC can still be configured to use the legacy implementation that we had in .NET 8. That definitely could be useful for testing as you're looking at adopting .NET 9 in your environment. And that remains supported in production. Okay, let's switch to ReuJIT. So ReuJIT is our, JIT compiler, obviously. In .NET 7, we released this profile guided optimization, or dynamic PGO feature. I like to think of it as the .NET recompiler. In this particular release, we went after casts. Interfaces and casting are all very common in C#. In this particular example, you can see that there's this isValid method that takes an ifoo. It has special logic if foo is a myFoo concrete implementation. If foo is commonly myFoo or commonly not myFoo, so basically on the two extremes, then the JIT will be able to go down a fast path, which makes the cast much more performant. And so that should show up as a win in a lot of different apps. Okay. So we're going to talk about loops. The team actually spent a ton of time on loops in this release. It's actually a commonplace for compilers to spend time on. So I just wanted to set the stage. Everything I'm going to talk about is about for loops, which are obviously very, very common. But so there's this website called sharplab.io, which I like. It's amazing. I think every .NET developer should spend at least a little bit of time there. I know our team spends a ton of time there. So if you type this exact for loop into sharplab.io, you'll see that the C# compiler lowers it to this while loop. So by the time the JIT gets it, it's actually not a for loop anymore. It's a while loop. And for each is exactly the same. So while I'm going to talk about for loops, I don't want you to think like, oh, I use while loops so they don't get any of this benefit. Not the case. Okay, so another compiler, common compiler optimization is strength reduction. And an example of that is turning multiplications into additions. So you might look at this for loop and say, well, I don't see any multiplications there, so how are you going to do this? Well, under the covers, before I say that, so there's this nums array, and we have to index into each element in the nums array as we make our way through each iteration of the loop. And so in .NET 8, the way that this was done is under the covers, it said something, this is all pseudocode, but this is more or less what happened, said address to nums plus I times 4. So that's clearly, that's a multiplication and an addition. The times 4 is there is because each int32 is 4 bytes wide, so we need to jump over 4 bytes to get to the start of the next integer. So in .NET 9, we're able to switch that to pointer to current element plus equals 4. And so we're able to grow, we're able to kind of grow this index or cursor or whatever you want to call it by 4 each time, which is great. And that was for arrays. Spans are a tiny bit different, but more or less boil down to the same thing. So address to nums plus I and then I plus 4. So we grow the kind of the size of 4 over time, and that's just due to the way biref rules work. So in both cases, we're able to remove a multiplication, which is valuable. This is specific to x64. On ARM64, there's a CPU capability that basically does all of this for free, which is great, so we don't have to get involved quite as much in the mechanics. Strength reduction can also be applied to your code. So for example, you might have code that says sum plus equals I times 3, and we can remove that multiplication as well. This exact example is covered in Andy's talk tomorrow, so I recommend taking a look at that. Another one, which I'm going to go over a bit more quickly, is called induction variable widening. That's a mouthful.
Nice.
Yeah, and what that is this is just purely on the signature of the loop. So I is a 32-bit value here, as you can see, but the JIT actually needs to, as it's actually using that, it needs to actually put that value in a 64-bit register, and so it needs to widen that value to correctly fit, and there's a CPU instruction to do that. In .NET 8, it actually did that on each iteration, and so with .NET 9, what it does is it widens I once for the entire loop, and then it actually within the body of the loop, it actually only reads the first 32 bits, and so more simply, widening is more expensive than narrowing. And this is, again, 64 bits, or sorry, x64 specific. It's less relevant on ARM64. So basically, that's another case where we've removed a cost per iteration. Okay, so let's talk about the host. We actually don't talk much about the host. Fortunately, actually, can you go back one more, because I need to briefly discuss this. Fortunately, we mostly built the host correctly from the start, and Other than some specific things, we actually haven't had to do a ton with it. So the host, just so we're completely on the same page, this is the app launcher. So if you build an app, like we made it so that dotnet apps, dotnet core apps had exes starting from, was it 3.0? Is that when? Well, self-contained apps have always had them, and then framework-dependent apps, I think, got them in 3.0 when we brought WinForms and WPF to the platform, if I remember correctly.
Yep.
So on Windows, that would be like myapp.exe, and then on Linux and Mac OS, that would be just myapp. Okay. Just so we're...
It's the thing that boots the app, right?
Yeah, it's just, so you can still do like .NET space myapp.dll, and people do that, but I think most people want exes and use them. So there's a hardware feature on Windows called Control Flow Enforcement Technology, another mouthful, we just call it CET. And so the app launcher, app host on Windows, it has this enabled by default now. And so it's a hardware protection against return-oriented programming attacks on Windows. So that's super important. It's not enabled for the .NET launcher, so if you do .NET Run, this thing is not currently turned on. It has a modest performance cost, but we expect that very, very few use cases will notice this. And so we absolutely recommend that you use it. And the last thing about this is we haven't really talked necessarily about these kind of like important security, what's the word I'm looking for, like mitigations. We've actually been building these over time. This is not the first one. There's actually some docs in our designs repo that actually outlines them. And so this is just another one of these in a path, and there will be other ones after this. But it's important that we implement these to just raise the security bar. Okay. This is actually a really cool one. So we've had some customers that have come to us over time and said, I want to build this suite of applications. Say I've got 6 apps, and I want to install them in just a directory. I don't want to have to install a runtime globally on the machine. And and so what we told them in the past is each one of those half dozen apps needs to be a self-contained app, and then obviously people would say, well, I don't like that because then you're duplicating the runtime and it's huge. So this feature basically says you can have, say, those 6 apps, publish them as framework dependent. They can still be in that private directory. There can just be one runtime that's there that they all share, which actually, by the way, makes that whole set of things easier to service as well.
So bring your own runtime, but you share it across your own.
Yeah, the feature actually has some other capabilities too. It's all about search behavior. The thing that I'm actually discussing is like the quote unquote relative path search behavior. It actually allows you the opposite thing as well. Imagine you wanted to configure the app to only ever use the global runtime and not look at anything else. The feature actually enables you to do that as well. And so we think that this just enables a ton more flexibility for certain types of scenarios, probably more in an enterprise environment, but also could be for a independent kind of system, independent software developer who'd like a photo, like a Adobe Cloud kind of a scenario where you have a bunch of apps that you're delivering to customers. Okay, I think we're going to go over to libraries. That's your area.
So now we go to the meaty portion, the core libraries. So the focus for .NET 9 has been the holy trinity of fundamentals, as I call it: performance, usability, and security. We've done about 4,000 types and members across the core libraries. So core libraries is basically everything with system or Microsoft extensions. So it doesn't include WPF, WinForms, ASP.NET, right? All the app-specific frameworks, right? This is all the foundational pieces that I'm talking about here. So we've done a lot of stuff. So I don't have time to talk over all of them. So I pick a random sample of what my favorites are. Hopefully you will like them too. But as Rich said, we have release notes. You should check them out. There's a whole bunch of goodness. And now we'll just jump into a few demos here. So if you do .NET, then chances are you deal with data import, data export. That's pretty common. So I have a sample code here where I basically have a string array of a bunch of strings, and they're effectively semicolon separated names. And all I want to do is for each line figure out how many names matched in some hash set of names that I have. So what I have to do before .NET 9 is basically I would have to go over all the lines, okay? And then I split all the lines, which then creates a ton of strings. And then I can use those strings to look them up, right? And that's obviously not great because you create a ton of string objects that you immediately throw away again. So one very obvious optimization that you can do is, since a while now, you can convert a string to a span. So now you have a read-only span of chars. And then you can call split. And so split on a span doesn't give you a new object or anything like this. It just gives you back a range, which just says effectively where in the span your hit is. And then you can use that to index into the span, which then gives you a new span. But because spans are just value types, they're super cheap, that doesn't allocate anything here. So the entire 3 lines here, there's 0 allocations. All we do is just find some locations in that string, and that's it. And then we use that span to index into the set. So if you know .NET sets, you might be like, how is that going to work? Because when you actually look at IntelliSense here, you see that our hash set of t only really takes a t, right? That makes sense. So there's only a string. So how do we actually use that? And the answer is there's a little trick here that is new with .NET 9. We call it alternate lookup. So all the core collection types, dictionaries, hash sets, across the frozen ones and the immutable ones, they all have the capability. So all you have to do here is, here's my hash set, and I say get alternate lookup for read-only span of char. And then what you get back is this kind of like nested wrapper type around my hash set. And now here I get a bunch of functionality that I can use. So for example, I also have add. And so I could do .add, and then it takes a span. And then so if the hash set already contains the span, it does nothing. If it doesn't, then it has to create the actual string object for you to put it in there. But it still means you're saving allocations. In our case, we don't even care about that. All we want to do is just look up the thing here. So again, this has 0 allocations here. And so when I ran a benchmark here, you can see the performance is roughly the same. I think I had about 10,000 lines that I tested it with. But the difference here is kind of in allocations, right? So this is 23 megabytes worth of string objects that are being created. And then the other one, and this is, I think, a number of GCs that happened. And then this is basically the almost constant size allocation, which you can pretty much discount for this wrapper type that we have, right? And so that's it. So basically, you again have a new way to do spans and do lookups in a cheaper fashion. Really cool. Go check it out. And I have another one here, which you've probably all seen in the wild for a while. So I have a little program here that asks me how old I am. If I'm truthful, then it tells me when I was born. If we try Rich here right now, he was born in 1994, but he's aged very gracefully. But if I do something like -10, for example, the process crashes.
1944.
Yeah, that's what I meant. And so then, we get an assertion failed here, which, as you probably know, an assertion is just an exception that is thrown when you do a debug build. And so it tells me the location, but it doesn't really tell me what assertion has failed. So if I actually want to figure out what happened here, I guess VS is crashing. Anyway, so like if we actually want to figure out what happened here, we actually have to look up the actual line where the assert was. And here it is, age was expected to be larger than 0. Now, if I want to see the condition, of course, I can copy paste this guy here. But then that's kind of lame because every time I change the condition now, I have to remember to actually change the string, right? Which nobody ever does. And then that's even worse because now you imply the wrong condition. So you don't want to do that. The cool thing with .NET 9 is all you have to do is retarget to .NET 9, not change your code at all. And if I now run it again, and wait for the console app to come back, then now we actually get the condition here. It says age is larger than 0. And so what actually ended up happening behind the scenes is kind of interesting. If we actually look at the implementation of assert, it basically calls this overload here that takes an optional message. And the message is attributed with call argument expression, which the compiler fills in for us. That's how we get the expression. But you see there's still this other method here, right? So there's still one that just takes the Boolean. So why does the compiler not call this one? And the answer is we have this new thing here called overload resolution priority. So we basically get to tell the compiler, yeah, this thing exists, but please deprioritize it because it's not as nice of an API for the user to use. And so basically you just recompile and you get the better experience. And we have done this attribute, we applied it to other parts of the core libraries as well to give you a slightly better experience. So that's the generalized feature here. Really nice and very easy. So I have another one here, a very simple console app here again. And all I do is I just print the menu here. And when you use my arrow keys, it highlights a different name. So the key thing here is when I render my list of people here, I basically say, is the current person the selected index, right? And the index happens to be an int here. So of course I do a for each loop here. So I don't have an index handy, right? So I can just, of course, create one here, but that's lame. That's an O of n lookup. Of course, I can also convert this thing to a for loop, but I don't want to. In this case, I could because it's a list of string. But you could imagine if people is just an IEnumerable or something that doesn't have an index, then I may not be able to do that. And so we added this new handy method here, a links extension method called index, which just gives you back a tuple of index, comma, the type. And now all I have to do is this, and I can just replace this whole thing here with index. And so every time you do a for each loop now, you want the index, you can just get it by using the index method. Really easy to use, super small quality of life improvement. I use it a lot in my code already. Really sweet. So then let's talk about tasks for a moment. So as you probably know, we do a lot of tasks, asynchronous operations in .NET. And so sometimes you just want to kick off a bunch of tasks and wait for them. So in my case here, I have a very simple task. All they do is they just count, and then they wait 1 second. So the first task will take 1 second, 2 seconds, and 3 seconds to complete. And so what you normally do is you say task when all. And so if I run this application right now, what you would expect is, the longest operation takes 3 seconds, so we have to wait for 3 seconds, and then boom, all the tasks are finished, right? But very often you don't want that, because basically all these tasks are independent. What I really want to do is I want to start working as soon as one of those tasks finishes. And so all you have to do now with .NET 9 is you can just say, we have this new method here on task.whenEach, and then you pass in the tasks array you want to wait. And then instead of giving you back a task, it gives you back an async enumerable of tasks. So all you have to do now is say await for each. And so if I remove this thing now here and I run it again, basically what happens is as soon as the first task is finished, it returns it, my loop starts running. So I can basically start processing tasks as they're being completed. And so of course you don't know the order. In this case, we know it statically, but most of the time you don't. So you just start working as soon as stuff is happening. And then here's some sample code that we did in JSON. Most of us use JSON serialization these days because it's very handy. And one thing with JSON is because you do serialization of types, you trivially have a schema in form of your types, right? So this is a library I got from Rich here. So he wrote a bunch of code to deal with our releases. And so he has an object model in C# that models our releases and the patches and so on and so forth. And then we encode them in JSON files. And so what we can just do now is we have this API here, JSON schema exporter, where you basically pass in your type, and then you can pass in some options. And what you get back is a JSON node, because the JSON schema itself is represented in JSON. And then we just write this out. And so what we end up here is we have a bunch of JSON files. And then, of course, with JSON files, you can point to the schema here, in which case, ironically, we get an error here because the schema doesn't include the schema property.
Yeah.
But
that's a thing.
But basically what you can do now is you get IntelliSense here. So you basically now have channel version. And if I say 9.0, for example, it tells me, hey, you can't do that because it really is supposed to be a string. And so when I put this in quotes again, it validates. And then also I get IntelliSense. In this case, I get description information, for example, which Rich extended this actually because there's no built-in version to do that. But we have a description attribute that Rich basically just intercepts and says, hey, if you have one applied, we insert stuff in the JSON schema that we export. And there's this transform schema thing here as part of JSON schema options where you can basically mess with the schema before you write it out. And so that's a very effective way for you to very easily get JSON schema information from your types. Now, I should say we don't have support in the runtime to validate JSON schemas. There's an issue for that if you want to vote for it. But we have a way to produce schemas at least, so you can use other tools to validate it. Or in my case, just drive the IDE and have code completion in your JSON files when you edit them by hand.
Do you have an example schema to show?
Oh yeah, so we have here the schemas here. This would be the schema, right? So
yeah.
we say here, what do we expect in the root? Well, we expect an object or null. And then you can say, hey, what are the properties of this? Well, there's channel version, it's of type string. Here's one of packages of type array. So you basically get to model the entirety of JSON.
And do you want to show the type,
The type, yeah,
view. I mean,
sure.
not necessarily that exact one.
So that's the one here that you have.
Yeah, so that's what the kind of Poco looks like. So in this case, I just used records. I absolutely love records, although these are particularly verbose records.
I was about to say.
Yeah, I still thought records was a good choice. Yeah, and then there's that property on each argument. Is that what they're still called for records? Yeah.
Yeah.
Yeah. I guess it's the only reason I'm pausing is because they're basically a primary constructor.
Yes. So they basically declare implicitly properties.
Yeah.
And so that's why you do the property colon thing to say I want this description to apply to the property, not the constructor parameter.
Yeah. So that's where the docs come from that I wrote.
Right.
Cool.
And you could usually use your own attribute, right? If you have your own attribute,
100%.
That's just the one which chose
Although
to use.
and you could put the docs somewhere else. They 100% don't need to be on the shape. Obviously, there's value in doing it this way.
Yeah, it's because it's built in. It's easy to use. All right, so before we go to the last one, I want to go to slides really quick. So we talked about features we added, but anybody can add features. We took features away this release. So that's something that very rarely happens. So hopefully you saw it this morning. Binary formatter is insecure. Stop using it. I know a ton of you use it because it's convenient. But we have started telling people for a long time that it's time to move off of it. In .NET 8, we marked as obsolete. We throw by default, even in .NET 8. But you can set a compat flag, and then we start working again. With .NET 9, we took the next step here, so we removed the implementation. So when you actually install the .NET 9 runtime, there is no implementation for binary formatter anymore. It's gone from the implementation. The APIs are still there, so we can load types that reference it. But if you try to invoke it at runtime, you get an exception. There is an unsupported compat package, and I will show that in a minute, that you can bring back the functionality. But the new thing here is it's unsupported, and it will remain unsupported. So in .NET 9, you can still bring it back. However, then you're unsupported. We really want you to stop using binary formatter. And hopefully this is not exactly news to you. We started circulating those plans in 2020 with .NET 5. And then in 7, we started removing our inbox dependencies on it, and then we marked it as obsolete, and we removed it effectively with .NET 9. So there's a migration guide as well. But basically the experience that you have with binary formatter, I want to quickly show that. So this is currently targeting .NET 8. So if you were to use binary formatter here with the usual thing, you just say new binary formatter, right? And then you start using it. It's already here in the IDE, you can tell, we already strike it out. We actually give you a squiggle here that's an error. So if you start compiling right now, it won't even compile in .NET 8 anymore because we basically marked it as obsolete with error. But of course, you can say, I want to suppress this one here. And then the warning will disappear. And then you can still do binary formatter.serialize with the stream and the data here that we have. And if you run this application, I mean, it's going to work, right? It's going to produce a binary payload. Well, in this case, not, because I haven't set the compat flag yet. So there's other thing we did in .NET 8 where you have to set this compat flag here to say, yep, I opt into this behavior, and now we're using it, and that's just the base64 encoded payload that it produces. If I retarget this to .NET 9, that's no longer enough. So on .NET 9, I have to rebuild, obviously. If I run this again, it will actually give you platform not supported exception because it's actually gone. So you can bring it back by writing the reference to this compat package that I mentioned earlier. So that's the system runtime serialization formatters package. I have some wonky version here. I think as of this morning, you just get to say this one here.
Right.
But when you actually use it now and you run it, the application is going to continue to work. However, you're unsupported now because the package is unsupported. And the other thing is, if you go to your output folder, unsurprisingly for the 9.0 version, there's this additional file here that you now carry with you because the runtime no longer has the implementation, right? You bring your own implementation effectively with that. And binary format is insecure. So now you're insecure still, but at least you get to use it. We see this thing mostly as a stopgap. If you want to migrate to .NET 9, you're not quite ready to remove your dependency on it, but you really should. And our formatting, our migration guide has recommendations what to do instead. It also talks about the compat package, but we really want you to move to different serializer, either JSON or data contract, protobuf.net, or message pack. These are the 4 recommendations that we have. But of course, you can bring whatever serializer you want. Just stop using this one, please, because it's not good.
Okay. So let's talk about the SDK. There are a bunch of improvements this time around, and so I'm just going to cover, I guess, my favorite set, as they say. Okay, so we were talking about security before. Going to talk about security again. So package vulnerability auditing has improved this time around. So this is a feature that was added in .NET 8, and in .NET 8, we looked at just direct dependencies to see if there were any vulnerable packages in your graph, not really the graph, just the direct set. This time around, we're looking at the complete set of dependencies. So this is why we use the word transitive. So both indirect and direct ones. And so we expect that users, once you move to .NET 9, you'll actually start to see quite a few more of these warnings. So these you will have had these vulnerable packages in your graph before. Just NuGet Audit was not telling you that. And so this is absolutely an important addition to the platform. If you look at other platforms, this sort of thing is becoming much, much more common. So we consider this to just be like the kind of the new reality and the new norm of software development, that you need to address these warnings. And we absolutely encourage you to treat these warnings seriously, update your package references, and kind of move on. So that said, I want people to know that there are some system.star packages that do report false positives. This is something we're working on improving quite actively. It's important that you still address these warnings. There aren't one set of warnings that you should address and another set they're okay. You should address all of them, and this should become cheaper over time.
Right.
Terminal logger is basically it's the new output of the CLI. The one on the right is the .NET 8 version. It's probably pretty easy to conclude that it looks a little bit stale. I think the one on the left looks a ton better, and so we're just modernizing the experience to make it look like what other development platforms have. And so it's basically pretty colors, better multi-line, a better way of incorporating either warnings or suggestions. In some cases, there's better summaries, like with tests. In other cases, as your as your app is being built, you kind of get this sense of progress, and then it changes. So I think this is just a overall good direction. I hope the team continues to move forward with this, because I think there's more that they can do. Like actual progress bars would, I think, be a good idea.
Yeah, recently, unfortunately, by accident, built with .NET 8 again, and I didn't like it. It's definitely an improvement.
Yeah. Before we move on to this, just to say more about that, the one thing that some people might not realize is, say, in your environment, you're all about .NET 8 development. It's like, okay, it's 100% .NET 8 apps. It's still fine to use the .NET 9 SDK. Like the .NET 9 SDK is 100% capable of building .NET 8 apps, and in fact, it will get a lot of use that way. So if there's developer nice life improvements that you can get from using the .NET 9 SDK, be like the security one or this one, we absolutely recommend you doing that.
Yeah. Always latest tooling.
Yes, yeah, latest tooling is definitely a good plan. So we've had .NET tools for a long time, I think since, I want to say .NET Core 2.0. So what those are basically, it's a different form of NuGet package. So you can take a tool, upload it to NuGet, and then anyone can install that on their machine. And then it's, for the most part, a command line tool that does something useful. And I think there's a bunch of those now. At the end of the day, those are just .NET apps and follow all the same rules as .NET apps. So they're bound to a particular .NET version. the developer of the tool can opt to set this roll forward setting in their project file to have it roll forward to a later version that you might have on your machine. And that's useful. That's a choice that person can make. Often they don't. So I've been playing with CPM. What's that stand for again?
Central Package Management.
Yeah, I've been playing with Central Package Management and Package Source Mapping this year. Great features. And so as part of that, I discovered this Package Source Mapper tool, which is actually quite useful. And so it turns out that it is built with .NET 6. You can kind of imagine reasons why they did that. And so I knew that this was a particular poster child for this use case. And so, on my machine, I either have just .NET 8 and 9, or in some of my machines, I just have .NET 9. And so, so you can type now .NET tool install, and then this allow roll forward thing. And so what it actually does is it configures this tool so that it can roll forward. So that's a choice that you're making as the consumer. And it works with both .NET tool install and .NET tool run. And so, I think this is a good thing.
Sweet.
Okay, I think this is our last slide. So back in .NET 7, I believe, the SDK added this feature which allows you to produce OCI images, aka Docker container images. Very, very useful. And the team has continued to improve that, added a ton of features. And actually, there's a nice community alongside the core team contributing to this. I know the folks at Red Hat have been contributing to this a lot, which is super good. So in my actually early experience of this, one of the things I wanted to do was to publish to a local registry. So the way the feature works is by default, you can deploy to the local Docker daemon, like Podman or Docker desktop. That's the default. You can push to a remote registry, and it's required to be HTTPS, so a secure registry. Or you can have it write a tarball to disk. So, I booted up this local registry, which was quote unquote insecure, meaning it's HTTP. That's what these two terms mean. And it refused to do that. It's like I only talk the language of HTTPS. So there was a workaround before, but it was a little bit not great. So this is a new experience where you can just there's a new environment variable called Docker container secure registry, and you can give I believe semicolon double limited list of all the names that you might want to push to. And so in this case, this is pretty awesome. So what I did is there's a Docker container on Docker Hub called registry. And so it is actually a container registry.
Right.
And so you can literally just run these commands. So I Docker run, -d means disconnected, so it's just running as a daemon. And then I set this environment variable. You can see that it's matching the port number that I specified in Docker run. I then created a new app. I published it, and I asked it to publish to localhost 5000 as test app. I then Docker run the app, test app, and then it goes and gets that, and I was able to then curl that app at localhost 8080, which is where I was hosting it on, and it all literally worked. That whole process took me like 2 minutes to figure out. So that was awesome. So I think
Sweet.
For the people that care about insecure registries, like basically this local scenario, it doesn't actually have to be on the same machine. It could be on another machine on your network. That's awesome.
Sweet. Yeah, so if you haven't downloaded it yet, you should. Hopefully you have done it already, given all the other talks that happened already. But yeah, you can just download it right now and play with it. And VS should have updated tooling as well, right?
Yeah, and I've been using .NET 9 as my go-to since, I don't know, Preview 2 or something like that? Preview
I think 3? So, yeah. Same for me. I've been on very early previews for .NET 9.
Yeah, so it's super solid.